Hello, everyone. So, I am with you guys from afar in Western North Carolina. You can hear the bullfrogs all around. But you will be seeing this tomorrow morning. It's 10:30. So, welcome to your first contributed session. And I want to do a special thanks to everyone on the committee who accepted my talk and also for allowing me to record this so that I could still be a part of things even though I can't be there in person. I really miss everyone, but I'm still excited to share my work with you all. So today I am talking to you about innovative assessments via creative projects. And looking through the titles and abstracts from different people, I know a lot of us, especially during the pandemic, were like, what are some alternate forms of assessment we can use? I started looking at this before, and I've been really interested in it for a while. And so I'm really excited to share that work with you now. So in fall 2018, I made my first dip into this alternate type of assessment. And so I introduced this idea into Math 113, which is excursions in mathematics. What is that? That's a great question. So this is a basic intro class that's all about problem solving strategies. So think draw a diagram, make a systematic list, things of this nature. And so I said, ooh, this would be great instead of just having them work problems to create something. So we had a problem solving project. That semester we covered 12 different problem solving strategies. And I said, show me what you learned about all of them. So dream big. They had their proposal due the 26th of October, and then they had to meet with me. They had like a week window to come meet with me and talk to me about it and narrow it down. And the idea was I was trying to help them find what is something you are super excited about, super interested in, because not all of them are super interested in math, but they all have interest in hobbies and are brilliant people. And so I was trying to help them tune into that and tell their math story through a lens of something they're comfortable with. And I said, okay, instead of doing a final exam, which we all know is a little bit stressful, you're going to do this project. It's still 15% of your grade, and here's the rubric we're going to use. And if you notice, right, it was 50 points per strategy for the description, uniqueness, and examples for each one. And then they had and 50 points for understanding of content. So out of this humongous rubric, way too high points, right? Very little of it had to do with the creativity, but really that's what I was looking for. So what were some of those initial projects? So I loved it. My students got super creative. I had a couple of theater majors who were like, math's not my thing, right? But they were able to tell me what they'd learned. One of them used screencasting. And so they had these like 3D mock-ups of scenes from a play that you could create. And they had a different strategy happening in each room. Super cool. Another one made a quilt. And so like, there was a different, let's say like piece of the quilt. Sorry for not having the technical language. Where they had, each strategy was represented with one of those pieces that you put together. I had another student who had started a film club at LR because he just loved writing scripts. He loved directing short films, like editing them, all this. And he was like, I'm going to edit a small film. He ended up making a script which was already rigorous enough that included all the strategies. I had several education majors who made scrapbooks, and they all came out very differently and very creatively, and they could do creative with the content, but also creative with how they're just displaying the content. I even had a student write poems, a different poem for each strategy. Very exciting. So then in spring 2019, the very next semester, I said, this worked so well. We are doing this as the final for both Discrete Math 1 and Calc 2. And a lot of you know what that means, right? This is a more rigorous course. Discrete's 3 credit hours. Calc 2 is 4. So you jam pack it with all this content. And I'm like, oh, that won't be a problem. This is going to be epic. So this time it was 14% of their overall grade, but it was still in place of that final. They had a proposal that was worth 100 points that they turned in late March. And then the first couple weeks of April, because spring got away from us, they had to meet with me and again another 100 points. And again, I had this ridiculous, because altogether, if you add up all these scores, it's 1,000 points. Like, why? But anyways, so if you look over here, you notice like creativity, neatness, attractiveness, overall effectiveness and completion, right? That's only 150 points of all of that. So if you're thinking like me, you're like 650 out of 800 was all based on like, do you know your content? So in Calc 2, that means like every topic we covered, and they had to have 2 to 4 examples of every topic we covered. Yes, I needed to think this one through a little bit more. So let's see what they came up with. All right, so in discrete math, I had a lot of students come up with games and computer programs that were games and this sort of thing. You can see here one example of that was Chutes and Ladders. She put the little pieces together and she had question cards that matched the colors of the space you landed on. Just like in Chutes and Ladders, if you land at the bottom of a ladder, you go up. And if you land at the top of a slide, you go all the way back down. So that was fun. And they actually went around during the final and like played those games. So it was really neat. And we had a potluck because this was pre-pandemic. And then you'll notice to the right that actually this student, one of our topics was Venn diagrams. And if you look very carefully and study this, you'll see what all the topics were that semester. And you'll notice what she did with the coloring is she looked at each topic individually and had information on it, but also like where they're dual colored is where she found the overlap. So she made a Venn diagram of all our topics, and I was like, this is wicked cool. I was super excited, but it was a lot of work. So let's see what Calc 2 did. So one student was like, I don't know what to do. I like Batman. And I was like, okay, so we brainstormed different ideas. And if you'll notice, right, area between curves, she looked at, okay, I'm going to model the curve for the top of the bat, the bottom of the bat, and then I'm going to find the area of the bat in the bat signal. I'm going to look at approximating the curve and using left and right Riemann sums, midpoint, trapezoid, all that, thinking about the cityscape. What? Okay, and you can see she's got her little crane over here as one of the things she did. She went all out. It was super awesome. Here you'll see another student created her own problems and an answer key. If you got the problems correct, then it told you, right, you match up and you know how to color the fish. Color by number. And this student was like, I'm not creative. And like, she killed it. It was awesome. Another student made these activity books for kids, and you'll see she split the units up into actually 4 activity books. And they were like kid friendly because they had all these cute little like creatures in them. And then there were some things that you could color. It was so fun. And so like really thinking about the material and how do you make it so that younger people might understand, might be interested. And like, for instance, she has the g of x function and then she finds the papa g of x function and it's the papa one. So it grew, it's bigger. It's so cute. I had another student create Mathopoly, and so you might have recognized Monopoly secretly hidden there. But she created her own rules for special spaces and special cards based on the different things we had in place in class and the different resources available to them. Funny, so funny. But then also when you think about the board to Monopoly, right, it gets harder and harder to get the property the further you go, and you get a bigger profit for getting those pieces. And so what was neat in her creating these problems is you had to solve the problems correctly in order to put property on them. And that meant the harder Calc 2 problems, in her opinion, happened later on the board. Super neat. And you can also see she was able to pull in a math major who loves 3D printing to create the pieces for her. So much fun. And my big takeaways for all of this is, you guys, for real, this was too much because my students who did really well on all of the topics spent way longer than I meant for them to. So I had some serious thinking to do before the next rendition. Luckily, that summer, I had the opportunity to redesign my excursions course, that problem-solving class, through wicked problems and thinking about, like, what do I want them to be able to produce at the end and how am I going to get them there? And we're going to, instead of just doing problems from the book, we're actually going to look at, like, prejudice and different things like this. And so we had to make time for that and things got adjusted. At the same time, I was developing my first year experience course, which I hadn't done before, and that one was on children's literature. So this really gave me a chance to say, okay, I did too much. How do I rein it in so that I give more students the opportunity to really shine? And let's see what I came up with. Okay, so for excursions, I said, okay, instead of doing all of our problem-solving strategies as a creative project, let's let them do one. And this semester, because I was more focused, we only covered 5 of them, and the students got to vote on them. And so they each got to do one, and we had someone who covered each of the different strategies, but like multiple people covered the same strategy in their own project, because those were done individually, but it was still that creative element. And then they also had a real world problem project. Again, that one was done individually, where they found a real world problem around campus and then like made progress towards solving it using the strategies we had covered in class together. And then as a team, they did a modeling project that was related to a community. So it either had to have to do with the werewolves and drugs model we did or with the prejudice polygons model we did. But so you can see they actually had 3 projects, but they were more focused projects. And they had 2 proposals, one for the problems, one for each of the individuals, the problem solving strategies and the real world problem project. So I still had them doing proposals at this point. And it seemed to work really well to have them be more focused. So this student looked at solving an easier related problem and noticed that her project was a lesson plan, which she presented as a PDF, like a Google slideshow. And so she had her objective, and then noticed she had 3 different problems. Remember, they had to do 2 to 4 problems, but just again for this one strategy. And so she actually had students work through it during our final and try it out. Here you're going to see our other strategies being represented by other students. And notice, right, we have the Find a Pattern worksheet, but we also have musical patterns. That student brought in his saxophone and modeled for us the patterns that you hear and then things that aren't patterns in music. And then we had another student, the one on the right, she was looking at Pokemon and like trying to approximate things based on like where you found Pokemon before and that sort of thing. Another student did another lesson plan on creating a physical representation, and she had something with M&Ms and something with someone else because she's going to be teaching elementary school students. So she looked at the strategy like, okay, how would I actually teach this to my students? Lot of fun, and it was really neat to see them come up with their own creative ways of showing the things and engaging with each other's projects. Also that fall, I got to teach Calc 2 again, and so this time, remember, we're being more focused. So we had 3 topic groupings: sequences in series, applications of integrals, and evaluating integrals. And there were several different topics we did in each one, and each student got to like make claim to one of those. So no 2 people had the same particular topic. They had to do at least 2 projects from the different categories, and then if they wanted extra credit, they had to do a 3rd one. And so they could do all 3 or just do 2. And so I only had 2 proposals due because they only had to do 2 of them. And so you'll notice the rubric is still quite large because you've still got this many points, and it's out of 200. But notice this time 120 out of 200 is based on how well do you know the content, and the rest of it is really digging in to like make this creative, make this your own. So let's see what they came with. So if you look here in the top left corner, you see that this student was doing work, and they made these 3D I don't even know how they did. They like render the problems and then they work through them and talk to us about them. So this one is like the work needed to pull this up. And this one is about the work needed to pull the bucket up. You can see the tiny bucket down here. This one on the bottom left is the difference between mass and density. And so she did kind of a science experiment for us and then talked to us about what's the difference between the 2 and how do we measure those. Why are these 2 like everything, not 2, why are all these things staying separate? Would they ever mix? That sort of thing. And then another student 3D prints. And so you notice for the divergence test, you've got 2 to the end. So this one sits inside this one, sits inside this one, and so on and so forth. And so you can see, like, if I take the limit, it's going to infinity, so it's diverging. But also, if you want to find the arc length, right, you have this circle. And so we can look at how do you formally find the arc length using the arc length formula you learn in Calc 2. And so he did that for the circle he 3D printed. And then another student you see was area between the curves. And so she just created her own problems. She had visuals, she had some fun facts. And so it's kind of like, it's just a poster, right? But it's done really well and very thoughtfully. And so it was just neat to see the variety and see how well they did when they were more focused. But also, when you're more focused and you choose the strategy, it really shows whether you understand the topic or not. as you're trying to explain it to us or put it into your own lens. So that spring in Discrete Math 1, I was like, let's do this. Let's focus on one topic again. But then the world exploded and everybody like went into their own little places, spring break, and then nobody came back because it was 2020, the year that good old COVID, everybody like became aware of it being a thing, and then everybody got really nervous about it and couldn't handle it yet. So we were asked to make things as easy as possible for us and our students to not overtax them during a really traumatic time. And so instead of having my students choose what lens they were telling a story through, I said everyone is creating their own excerpt for a graphic novel. So we were already using Eric's graphic novel that he talked about at a previous ACMS meeting. So shout out to him and a big thanks for creating that text and introducing it to us, because I love using it with my discrete kids. And they actually enjoy reading that a lot better than a textbook, I found, which is really nice. And so what you'll see here is I made like a specific rubric for this, because now they have a story, effectiveness, and organization, because they're making a little story. And you'll see the different topics we had because they were each focused on a particular topic. So here you get kind of a sense of how they put all that together, because they have all these panels for their comic. And this one is in particular on set theory. And then you can see this one's on graph theory and trying to get all those definitions with these two little kids. And it was neat to see some of them hand drew them. Some of them found like free online like templates. People came up with all sorts of things to do this. And I think overall, like, I don't know that they loved it because they were super stressed about a lot of things, but they also didn't hate it, which I felt like was a win. So then in fall 2020, I was thinking about how do I improve on what we've been doing? And I said, you know what? Let's have a couple of days in class where we actually talk about projects. I actually get them to brainstorm with each other and talk to me about like what sorts of things could you do, get them to start dreaming big so that they're ready to do their proposals and then create their projects. And then we have the extra bonus of we're still not quite sure how to deal with this. Everybody goes home for Thanksgiving. We think we're going to have another week of classes and finals. And it's like, surprise, we're not coming back because we're nervous about COVID. And so everybody's doing remote finals now. So again, remember they have two that they have to do and then a third one that's optional. So everyone did their first one on the 30th of November and everyone did their second and or third one. Yeah. On the 2nd of December. And you'll notice the example one that I put in here for you is finding the area of between curves. And you notice that he found examples in real life for the area between curves horizontally and vertically. And you can kind of see like how different they are, which is really neat because some of them have like more curvy on both and some of them have a straight edge on one side. And then he went through the process of how to find it for each of those. Which was really neat. And remember, they're having to do it on Zoom. So a lot of the ones this semester, all of them, right? A lot of them are PowerPoints because that's an easy thing to share on Zoom. Okay, so I know this slide is really busy and I am going to talk to you about this. So we actually in spring 2021 tried to be more normal, but then also we shrunk all our class sizes still. And so we had like 4 final exams slotted to us because we met weird ways that semester. And so craziness, but that meant people had time and like could actually present all 3 projects if they chose to do all 3 on different days. So it ended up working out okay. But then notice, right, we still had 2 class days separate, and I moved the first class project day like after midterm but halfway through the semester so that students had a chance to like do their proposal for the first one and could start really thinking about it and even start doing it if they wanted to. And then the other one was much closer to the actual final exam time. But I found like sometimes people felt like in the past that they had been too rushed to try and do both. And so I wanted to kind of spread that out for them a little bit. So what you'll notice here is work being applied to life. And he had his little, it's not a hamster. Sorry about the sound. Hopefully it's all fixed now and you can see me again. So this is a hedgehog, the cutest hedgehog ever. And this is him walking. And that's one work problem. And here's him running to his food. That is a faster work problem. And then you also have another student who did memes, and he did that for the limit comparison test. And what you'll notice here is you're trying to figure out what to do with 5 over all this junk. And then you're like, oh, that's basically into the fifth, because if you compare into the fifth to 3 n squared, into the fifth just engulfs the 3 n squared. And so you've got the double Spider-Mans being like, wait, are we the same? Because they basically are, at least in math. All right. And then also they look the same in the meme. So that turned out brilliantly. I'd never really known anything about memes before, but my student was super excited to try it. We were laughing the whole time, and everyone was super engaged. And then I had another student who did volume, and she looked at both the disc and the shell, vertical and horizontal, and she was like, I love the summer and going to the beach. So you've got the inner tube, and you've also got the donut, and then you've got the ice cream cone. And you can see here, for Power Series and Interval of Convergence, she created a lesson plan. Her plan is to teach high school, so she directed it for that audience. So another student did stop animation, which is something he's really passionate about. And as you can see here, this is him trying to show that a sequence converges to 0. And what you'll find is it all goes away. He also did converging to 1 and diverging, which just builds and builds and builds. And what was great about this particular student is he's struggled the whole semester, doesn't do really well with traditional exams and using really technical language. And so projects really let him dig into, like, does he actually understand what's going on? And so then we're really able to uncover that in a way that traditional exams doesn't let us do. That spring, I taught discrete math 2, and I had 5 students, and they were all upper level students who I felt really confident saying, you know what, let's scrap traditional exams and portfolios and all this, and let's focus on projects. So they did a traditional, what I call traditional, creative project with the basic counting principles. So one kid, he did chess, and he showed us all the different counting principles using a chessboard and other things like that. And then the second project they did was an application outreach activity. So think Julia Robinson type type problem. So we're introducing you to this deep math idea, and you're uncovering truths about it, even though you don't really know that idea or maybe never even heard of it, but you actually understand it intuitively. So for instance, I had someone look at lattice paths as like directions from where she lived to where she was going to live with her husband. So that was pretty neat. And then we have the social media series, which was the culminating project, where they had, for each of our learning outcomes, they had to create a separate post, at least one post. And so they're looking at, for instance, one of the outcomes was solving a problem in multiple ways, right? Making mistakes, struggling, and persevering. And so it was really neat to see. I had 2 students who did it on Instagram and 3 who did it on TikTok. 2 of them did it, so 4 of the 5 did them where everybody could see, and it was neat to see the interaction they had with people. And then in Calc 1, I used team-based inquiry learning for the first time, and I was encouraged to use mastery grading, which I hadn't done before, and I was like, I still want to use projects, but related rates and applied optimization, I didn't really like doing those as masteries, so those were projects for my students, and you can see that they were rendering things, they were creating projects, they were creating 3D objects, creating lyrics and singing for us. And I had a rubric, and they had to do double mastery for each outcome. So they were able to master each of those 2 outcomes twice in one project, because they had to have 2 examples at least. And then they had the creative aspects that would give you the other. So you could miss technically one of your problems and still master this outcome because of the creative elements. And that's kind of how I blended the 2. This past spring, I was so excited about how well it worked in my class of 5 that for discrete math 1, which actually had 24, I decided to do just projects, no other types of assessment. And so they had to, for the first one, they did a proposal, and then they did the project and a reflection. So they talked about what did they think went well, which parts of the rubric, like the creativity, the content mastery, all of those things, what would they do differently? And then for each subsequent project, because the first one took so long in class, the next 3 they had to do using GoReact, which is an online submission video. And so then the last 2 they did during our final exam period. And I had them slowly get better at their time management so that we could do that during the final. The rubric here matches what it was before, except for everything is scaled back to be out of 20 points instead of the 200 that we had most recently. And so I feel like this worked really well, but I feel like having a proposal for every project helps keep the students on track more. And the most reoccurring thing was students saying, I should have started earlier. So if I can get those proposals from them, that will help. I wonder about what questions you guys might have, but since I'm not there